All right, so we are talking about 2.1 relations and functions. All right, so there's actually multiple things we're going to learn in this lesson. And the first thing is, when is something a function versus just like a relation? A relation is like a little more broad. It can be anything. A function is a little more specific. It has to meet like a requirement, okay? So for the first one, all right, what is a function? Sorry, let me grab my iPad pen here. Does anybody know? Does anybody remember from, I don't know if you guys learned this in Algebra 1, but does anybody remember what makes a function a function? Anyone? No? It's been too long. Geometry wiped out all your algebra knowledge. All right, no worries. So a function, this is the rule that makes it a function. All right, so it's a function if each x has only one y. Okay? Oh, you guys can't see my writing, huh? But each x only has one y. Give me a sec. Let me help with this connectivity real quick. Okay, hopefully that fixed it. Okay, so each x has only one y. And when we talk about the independent variable, this is the x variable. That's our independent variable. And our dependent variable is our y variable. Okay? And this is where we get the domain is from the x variable. And when we ask about range, this comes from the y, our dependent variable. All right. And lastly, there's a thing called a one-to-one function. All right, so a one-to-one function, it's still a function. So every x has only one y, but it also satisfies the criteria that each y also has only one x. So each x has only one y still for it to be a function. And each y has only one x. All right. So we're going to see some examples of that, and then yeah, and then we'll see if that makes sense. The last two things I do want to tell you guys about is the difference between a discrete relation and a continuous relation. Okay, so a discrete relation is when you have isolated dots. Okay, so if you have to pick up your pen to draw the graph, that's discrete. Whereas a continuous one is smooth. All right, it's smooth, it's continuous. So you don't have to pick up your pen to draw it. Okay, so that is a continuous relationship. All right, so let me go ahead and give you guys some examples of the relation versus a function versus a one-to-one, and let's see if that makes sense. All right, so let's start with a relation. Okay, so a relation can be any sort of relationship. There's no criteria at all. So for example, let's say 1 goes to B, it's connected to B. 2A, 2B, 3C, and 3D. All right, so that is a relation. All right. Now, for it to be a function, right? So this relation is actually not a function because every x doesn't just have one y. For it to be a function, each x can only go to one y, like that. So this is a function. Notice there's only one arrow going out of each x member, but in this one, notice that here, there's two arrows coming out of that, and there's two arrows coming out of that. So that is not a function, whereas the second example is. There's only one arrow coming out of each of these x's. This, however, is not a one-to-one function because these guys are sharing the same y, right? So every y doesn't just have one x. So to give you an example of a one-to-one function, it would be something like 1a, 3b, 2c. That would be a one-to-one because you only have one arrow coming out of each x and you only have one arrow going to each y. So that makes it one-to-one. Any questions about the difference between a relation, a function, versus a one-to-one? Did that make sense?
Wait, so just in case I like missed some stuff, you can upload the notes to like the correct like lesson note. Now you have like the answers. Do you still do that? Oh, sorry, I can't speak right now.
Sorry,
like
yeah, the internet's a little glitchy.
Yeah,
Are you asking for the answer key to the worksheet?
No, the answer key to like the lesson notes.
Oh, this lesson.
Yeah.
So what I'm doing is I'm videoing it. So then just go on YouTube and then it's basically the answers right there.
Okay, it's just on, do you have a link to your YouTube like on your Schoology?
On Schoology, yes.
Okay.
It's on Schoology front page. Yep.
Okay, awesome, thank you.
Good question, yeah. Okay, so I was trying to think of analogy to help you guys remember like when it's a function, when it's like one-to-one and when it's not. And okay, this is a little biased because this is like my life with my baby and stuff. Oh, which by the way, I decided Mondays are gonna be baby picture Mondays. Okay, so I know some of you guys like probably don't even care, but I'm gonna show you guys a picture of my baby every Monday. And that way you guys can kind of see him grow up because you guys, you're catching him on his first year of life and he's gonna change so much. So regardless if you care or not, here is your baby picture Monday. And there he is.
So cute.
See him, but that's Jared, that's JP. Yeah, he's starting to grow out of outfits, so we did like a little fall photo shoot, like fall line photo shoot, but there he is. That's my baby. But yeah, okay, so how it pertains to the lesson. So I was thinking, I'm like, okay, how can I give you an example of a relation versus one-to-one? Okay, so I think I got it. I think I got a good example. Think of the domain as babies, okay? And think of the range as biological mothers. I'm not gonna write biological, but I'm just gonna write mom. Just to shorthand it, but I mean biological mothers, okay? So it's a relation, but it is not a function because one baby can't have two biological mothers. So it's not a function, okay? It's not a function. So here, this passes the test because baby, mom, this baby has one biological mother, this baby has one biological mother, and this baby has one biological mother. 1 and 3 share the same biological mom, but that's okay. All right, that's totally fine. They're siblings. Okay, so that's why it's a function. All right, now a one-to-one function is when you are the only child. Okay, you are the only child. Okay, so only child. So baby and mom. So this baby has one mom, this baby has one mom, this baby has one mom, and they're all only children. So that means it is a one-to-one function. All right, so does that help? I don't know. All right, hopefully that helps. Actually, you know what? I'll do this. I will offer you guys extra credit if you can come up with your own analogy for a function and a one-to-one, okay? I want you to come up with your own. Email me the analogy and an explanation of, like I just showed you, like when it's a function versus a one-to-one. If you guys can give that to me by the end of today, I will give you extra credit, okay? All right, so there's your first extra credit opportunity. All right, let's go to our graphs here. So let's try it with our graphs. So with our graphs, okay, oh, I'm gonna go a little faster now. All right, with our graphs, to test if it's a function, okay, so I'll go ahead and write this down here. You're gonna do the vertical line test. Is to test, is it a function? All right, so in this case, it doesn't pass the vertical line test. It hits it twice, so this is not a function. Okay. This one, it does pass the vertical line test, so this is a function. And this one passes the vertical line test, only hits the graph once, every vertical line, so this is a function. Now, to test if it's one-to-one, you do a horizontal line test. So is it 1 to 1? Now here's the thing. If it's already not a function, you don't have to do the horizontal line test on it because it's not even a function, so it can't be a 1-to-1. So I'm not even going to do it on the first graph. But this one, horizontal line test, it does not pass. So this is not 1-to-1. This one does pass the horizontal line test. So this is 1-to-1. All right. Any questions on how to tell if a graph is a function or if it's 1-to-1? Okay. All right. Flip your notes over whenever you are ready. Okay, here we go. So on to the back side. So on the back, we're going to talk about like domain and range. We're still going to talk about some function, and we're also going to talk about function notation. So yeah, big lesson today. Okay, let's see if I got everybody back yet. Joseph's back. Jackson's coming back. Somebody left. Okay.
Joseph's thing crashed.
Oh, got it. Thank you.
Yeah.
Okay. Okay, Michael, Brendan. Let's see. Zoe. All right, hopefully they'll make their way back soon. All right, here we go. So onto the back first, domain and range. Okay, when you do domain and range with the table, super easy, okay? Domain is the X, range is the Y, all right? So you just write D for domain, and I'm gonna do these little braces. And I'll write down all the x numbers. Okay. And if there's any repeating numbers, you don't have to write the number twice. You just write each number one time. All right, the range. I have a 0, a -1, a -2, and a 4. Oh, actually, I should put that in order. Sorry, guys. So the lowest is -2, then -1, 0, and 4. So yes, please put that in order, ascending order. All right, so we stated the domain and range. Now we have to determine if it's a relation, if it's a function, or if it's one-to-one. So at the table, what I'm looking for are any repeats in the x's, right? So here, I don't see any repeats in the x's, meaning every x only has one y, right? Every x only occurs once. So that means this is a function. Okay. Now, to determine if it's one-to-one, I look to see if there's any repeats in the y column, all right? And I do notice, I have 2 zeros. So that means this is not 1, 2, 1, because the y value of 0 has 2 x's, all right? That's 2 x's. So that's why it's not one-to-one. All right, let's jump to number 3 so you guys can see the table one more time. So for number 3, same thing, I'm gonna do my domain. I'm gonna list my x's in order. So -2, -1, 1, and 2. Range, I got -1, 0, and 1. All right, so now, is it a function or not a function? What do you guys think? Anyone? Function, not a function. What do you guys think?
Not a function.
I heard not a function. Good. And why? Why is it not a function?
It has repeat.
Yeah. You got a repeat on the -2. So the x value of -2 has 2 y's. It's like in the mapping, if this -2 had 2 arrows coming out of it, right? So that is not a function. All right. And if it's not a function, you don't have to check one-to-one. You're done. If it's not a function, you don't even have to check one-to-one. Okay. All right. Let's have you guys try number 2 and number 4. Go ahead and try number 2 and number 4. I'm going to call on people once they're done. Oh, actually, sorry. Number 2, let me help you with the domain and range first, and then I'll have you guys go. All right. So for the domain and range, for number 2, how I do domain and range with graphs is I kind of imagine like a scanner, kind of like at the grocery store, you know, when you kind of like move things across that clear plate and it like scans it. I kind of imagine that. So it's like I'm scanning this circle, and for the domain, I'm scanning it horizontally, right? So I'm like scanning, 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 scanning. And I'm basically asking, where do I hit graph? Where do I hit graph as I scan along the x-axis? So I have graph starting at 0 all the way until 10. That's where I hit graph as I scan horizontally, okay? So I have anything from 0 to 10. So 0 less than or equal to x, less than or equal to 10. All right. Now for the domain, or sorry, for the range, I'm going to go ahead and scan along the y-axis. Okay, so I'm going to scan this way. So I'm scan, see where do I have graph? And I have graph from this value all the way up to this value. That's where I have graph as I'm scanning along the y-axis. So my range is going to be from -2 to 8. Make sure, oh, is that 8? Oh, it's a little above 8, sorry. Let's do 9. All right. And make sure you use a y for that range and not x. Okay, any questions on that? Okay, all right, so let me go ahead and have you guys decide for number 2. Is it a function? And if it is it 1-to-1? I'm gonna call on somebody. So decide for yourself, is it a function? And we'll start there. All right, and let me ask Joanne. Joanne, what do you think? Number 2, is that a function?
Yes,
Okay, and why? How are you testing it?
because there's no repeating numbers between 0 to 10.
True. For a graph, use the vertical line test for graphs. So does it pass the vertical line test? It does. No, it doesn't actually. Because if you slice it, does it only hit the graph once? Every vertical slice? It has to only hit once. So does it only hit once?
Yeah.
This slice that I made through the graph, it only hit the graph once?
No.
No, it's hitting it twice. One here and one here. So does it pass the vertical line test?
No.
It does
No.
not. So what does that tell us, Joanne?
It's not a function.
Good, yeah, so this is not a function. So should I try the horizontal line test?
No,
No, why not?
because it's not a function.
It's already not a function, so you're done. You don't have to check if it's 1-to-1 because it's not even a function. So we're done there, okay? All right, sweet. Number 4, let's see. Paolo, number 4, can you help me with the domain?
I didn't get the domain yet.
It's okay, work on it right now. What should the domain be?
It'd just be 1, 2, and 3 then.
Yeah, you got it. Nice. Okay, and then the range, Liam, what should the range be?
2, 4, and 6.
Perfect.
Right? Yeah.
Yeah, you got it. You're good. Nice. Okay, so now the question is function or not a function? So everybody really think about it. Function or not a function?
I think it's a function.
Okay, and Ethan, why?
Isn't it because there's no repeating numbers from 0 through 10?
Oh
Oh wait, yes there is. Never mind.
wait, for number 4? You're
Yeah.
asking, yeah, so the question is, are there any repeating numbers in which column, X or Y?
Oh, there's no repeating numbers in a column, but 2 is in both columns.
Well, okay, so that's a good note. So here, to see if it's a function, you just look at the X column. So are there any repeating numbers in the X column?
No.
No. So that means it is a function. Okay. All right. So now the follow-up question is it one-to-one? So everybody go ahead and think about that. Is it a one-to-one function? What do you guys think? Go ahead and just unmute. Tell me when you think you got it.
It is one-to-one function.
Good, Yanni. And tell everybody why.
There's no repeat on the y or range.
Good. So there's no repeats on the y column. So this is one-to-one. So Ethan, good catch actually. There is a repeat, across the columns, but that actually doesn't matter. It only matters within the column, and that's what you check. Okay?
Okay.
Good. Okay, any questions on determining if it's function, one-to-one, domain, and range? Okay, let's get to our last section here, guys. Okay, so our last section here is what's called function notation. Okay, so function notation, number 5, really quick. If I wanted to write this in function notation, it's really simple. You just replace the y with an f of x. All right, you just replace y with an f of x. So this is just f of x is equal to 2x plus 3. And that's what that looks like in function notation. Okay. All right, so how function notation is just, it's a bunch of substitution. So like number 6. Number 6, I'm going to substitute x right there in for 3. All right, or I'm going to substitute 3 in for x, I should say. So with my function f, every time I see x, I'm going to replace it with a 3. So I replace that x with a 3, and then you just simplify. And that's it. Okay. Same thing with number 7, f of negative 4. So I have 5 over negative 4 plus 2. So I get 5 over negative 2, which is negative 5 over 2. All right, so that's it. You just substitute this number in for the x. Same thing with number 8, except this time we have g of x. So g of x, this is my function g of x right here. I'm going to substitute 1/2 for that x. So I have negative 2, plug in the 1/2 for x, and then simplify. And that's how it's done. All right, any questions before I start calling on people? Okay, all right. Help me with number 9 then. Let's go to Mateo. All right, Mateo, number 9, what would you do? Tell me what to write.
Got confused.
Okay, so Mateo, what you do is look for the f function, which is right here, and you substitute negative 2 in for the x. Okay, so what should I write?
5 over negative 2 plus 2.
Perfect, good. So that's gonna be 5 over, keep going, 0. And what's 5 over 0?
0.
No, it is undefined. You can't divide 5 into 0 groups. That is not possible. So undefined. undefined. All right, good job, Mateo. Number 10, Michael Y. Help me out with this one.
Okay, so you're going to do -2 times -6 plus 3.
Nice. Keep going.
So you get 12 plus 3, and the answer is 15.
Perfect. Good job, Michael. All right. Okay. This one is the true test, if you understand. Number 11. So try it out yourself and then look up once you're done. See if you really got it. So this is the true test. All right. So if you look at what I did, hopefully you guys did the same thing. We just plugged in m-2 in for the x, simplified, and I got 5 over m, and that's it. Okay, that's all the time we have for today, guys, which is okay. The word problems are pretty much the same thing. It's just, you know, asking for the domain and range, which is just your x for the domain, and the range would just be all your y's, and it's just asking if it's discrete or continuous. Hopefully you guys would pick discrete since they're isolated points, and you can tell if it's a function or not depending on if the x repeats or if the y repeats. And then the last one is just substituting in, so it's actually not too bad. All right, good job, guys. Have a good rest of your day. You guys have homework today for lesson 2.1, okay? Bring questions tomorrow. All right, good job. Have a good one.
Thank you.
Bye,
Thank you.
guys.